Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable questions. So let's get going. Problem solve x cube into d cube y by dx cube plus 2x square into d square y by dx square plus 2y equals to 10 times x plus 1 by x. So we are given a differential equation with variable questions. Now we are going to reduce this to a differential equation with constant question by making some substitution. Given differential equation, x cube into d cube y by dx cube plus 2x square into d square y by dx square plus 2y equal to 10 times x plus 1 by x. So we know that differential operator d equals to d by dx, then d square will be d square by dx square and d cube will be d cube by dx cube, right? With independent variable x. Now, the above equation becomes x cube into d cube y plus 2x square d square y plus 2y equal to 10 times x plus 1 by x, right? Now take y common from all the three terms of LHS. We'll get x cube d cube plus 2x square d square plus 2 into y equal to 10 times x plus 1 by x, which is a Cauchy's equation. Now let's make the substitution. Put x equals to e power z, then log x to the base c equals to z for x greater than 0. Let theta equals to d by dz, where theta is a differential operator with independent variable z. Then xd equals to theta, x square d square equals to theta of theta minus 1, and x cube d cube equals to theta of theta minus 1 into theta minus 2. Okay. Now this Cauchy's equation becomes, x cube d cube. Replace x cube d cube by theta of theta minus 1 into theta minus 2. Plus 2 into, replace x square d square by theta of theta minus 1. Plus 2 into y equals to 10 times. Replace x by e power z, will get e power z plus 1 by e power z. Okay. So we have xd equals to theta and x square d square equals to theta of theta minus 1, right? We can write it as theta square minus theta, right? Theta into theta, theta square minus theta into 1 theta. Now coming to x cube d cube. This equals to theta of theta minus 1 into theta minus 2. We know that theta into theta minus 1 is theta square minus theta into theta minus 2. This becomes theta square into theta is theta cube minus 2 into theta square is 2 theta square minus into plus minus theta into theta, theta square minus into minus plus theta into 2, 2 theta. This equals to theta cube minus 2 theta square minus theta square is minus 3 theta square plus 2 theta. Now we can replace theta into theta minus 1 into theta minus 2 by theta cube minus 3 theta square plus 2 theta. Okay, directly. Plus 2 into, replace theta of theta minus 1 by theta square minus theta, because theta into theta minus 1 is theta square minus theta, right? We'll get theta square minus theta plus 2 into y equal to 10 into e power z into 1 by e power z can be written as e power minus z. Now this equation becomes theta cube minus 3 theta square plus 2 theta plus 2 into theta square 2 theta square minus 2 theta plus 2 into y equal to 10 times e power z plus e power minus z. Right? Now, this equation becomes theta cube minus 3 theta square plus 2 theta square is minus theta square plus 2 theta minus 2 theta gets cancelled plus 2 into y equal to 10 times e power z plus e power minus z, which is a differential equation with constant coefficients. And also, this is in operator form f of theta into y equals to some function of z. Right? Where function of theta is theta cube minus theta square plus 2. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. So we'll find yc using the auxiliary equation. Later we'll go for yp. Okay. So firstly, let's find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta cube minus theta square plus 2, right? Let's replace differential operator theta by m so that we'll get f of m equals to m cube minus m square plus 2. Now our auxiliary equation becomes m cube minus m square plus 2 equal to 0. Now we need to find roots of this equation, right? So we are going to use synthetic division method to find roots. Now consider the polynomial m cube minus m square plus 2 and see which m satisfy this polynomial. Firstly, I'll go for 1. When m equals to 1, we'll get 2, which is non-zero. So m equals to 1 does not satisfy this polynomial. Let's go for m equals to minus 1. We'll get minus 1 whole cube minus of minus 1 whole square plus 2, which is equals to minus 1 whole cube is minus 1, minus of minus 1 whole square is 1 plus 2. This is equals to minus 2 plus 2, which is equals to 0. So m equals to 1 satisfies this polynomial, right? So I forgot to place the coefficients of m's in the synthetic division. Let's place it properly. This is 2, right? Coefficient of m power 0 is 2. Put 0 here. We'll get 1 plus 0, 1. Minus 1 into 1, minus 1. Minus 1 minus 1 is minus 2. Minus 1 into minus 2 is 2. 0 plus 2 is 2. Minus 1 into 2 is minus 2. 2 minus 2 is 0. Again, this gives one polynomial m square minus 2m plus 2. Let's see which m satisfies this polynomial, okay? Let's go for 1 firstly. We'll get 1 minus 2 plus 2. 2 minus 1 gets cancelled and we'll get a non-zero number 1, right? Now let's go for minus 1. Let's try for minus 1. We'll get minus 1 whole square minus 2 into minus 1 plus 2, which is equals to 1. Plus 2 plus 2, which is equals to 5. Again, a non-zero number. Likewise, when you go for 2, you'll get 2 square 4 minus 2 2s are 4 plus 2. You'll get 2, a non-zero number. So we are not going to get a proper number from this polynomial. So what we'll do, we'll just write the polynomial m cube minus m square plus 2 as, see, from m equals to minus 1 we'll get m plus 1 equals to 0, right? Here we'll take m plus 1 as one factor, and also these numbers gives another factor, say factor, m square minus 2m plus 2, or another polynomial we can call. So we can write m cube minus m square plus 2 as product of m plus 1 into m square minus 2m plus 2. Okay, so we can write this equation as m plus 1 into m square minus 2m plus 2 equals to 0. Now we'll find roots of this equation. Okay, it is a quadratic equation, right? So let's go for quadratic formula. Just compare this equation with quadratic equation in m, am square plus bm plus c equals to 0. Then we'll get a equals to 1, b equal to minus 2, and c equals to 2. Now consider quadratic formula m equals to minus b plus or minus square root of b square minus 4ac by 2a. This is equals to minus of b is minus 2 plus or minus square root of minus 2 whole square minus 4 into a, 1 into c, 2 by 2 into a, 1. Okay, this is equals to 2 plus or minus square root of minus 2 whole square is 4, minus 4 2s are 8, minus 8 by 2, which is equals to 2 plus or minus square root of 4 minus 8 is minus 4 by 2. Right, we can write minus 4 as square root of minus 1 into 4 by 2. Again split square root of minus 1 and square root of 4 as into square root of 4 as, sorry, square root of minus 1 into 4 as square root of minus 1 into square root of 4. We know that square root of minus 1 is I and square root of 4 is 2. Then this becomes 2 plus or minus I into 2 by 2. Right? Now take 2 common from the numerator. You will get 2 times 1 plus or minus I by 2. Now cancel 2 from the numerator and the denominator. Then you will get 1 plus or minus I, which are roots of this equation. Right? Fine. See, when you equate each factor to 0. When you equate m plus 1 to 0, we will get 1 root m equals to minus 1. And when you equate this quadratic equation to 0, we'll get, quadratic polynomial to 0, we'll get m equal to 1. This is 1 plus or minus I, right? A pair of complex conjugate. So therefore, m equals to minus 1 and 1 plus or minus I are the roots of our auxiliary equation. So we got one real root and a pair of complex conjugate roots. Therefore, minus 1 is a real root or real and distinct root, and 1 plus or minus I is a pair of complex conjugate root. Right? Now coming to complementary function. This is minus 1 not I. When we have m1, which is real and distinct root, then yc will be 1 constant into e power this root into independent variable z. Okay. We know that a plus ib is a complex number. Then its conjugate is a minus ib. Likewise, if a minus ib is a complex number, its conjugate will be a plus ib, right? Then we can call m equals to a plus or minus ib as a pair of complex conjugate roots. If we get a plus or minus ib roots, then yc will be, we need two constants, right? Already we have used one constant c1. Now let's take another two constants c2 and c3. Let it be e power a into z into c2 cos bz plus c3 sin bz. Okay. Now let's write our complementary function. Now let's write for the distinct root. Then yc equals to c1 equal distinct root into z plus, now we are going to write for the pair of complex conjugate roots. E power 1 into z into c2 cos, for b equals to 1, compare a plus or minus 1 plus or minus I with a plus or minus ib. Then for b equals to 1, we'll get 1 into z plus c3 sine 1 into z. Right? This equals to c1 e power minus z plus e power z into c2 cos z plus c3 sin z. Now we are having yc in terms of z, but we need to write in terms of x. So that we'll replace e power z by x and z by log x. Right? In order to replace e power z by x, we need to write e power minus z as e power z power minus 1. Okay? And write the second term as it is. E power z into c2 cos z plus c3 sin z. Then this becomes c1, replace e power z by x, we'll get x inverse plus x times c2 cos of, replace z by log x, we'll get cos of log x plus c3 sin of log x. Right? Or we know that x power minus n is equals to 1 by x power n. Then we can write x inverse as 1 by x, right? Or we can write it as c1 into 1 by x plus x times c2 cos of log x plus c3 sin of log x. Okay, c1 into 1 by x is c1 by x. So I'll change it here itself. I'll write c1 by x. Okay, either we can write yc like this or this. You can choose either of these two. So we got yc. Let's go for yp. So we need to find yp now. Particular integral. We'll find yp using 1 by f of theta into q of z. We have f of theta and q of z, right? Where f of theta is theta cube minus theta square plus 2 and q of z is 10 times e power z plus e power minus z. Or we can write it as ten into 1 by f of theta into e power z plus e power minus z, right? Which is equals to 10 into 1 by f of theta into first term e power z plus 1 by f of theta into e power minus z. Theta cube minus theta square plus 2 into e power minus z. Now let's find each term separately for our convenience. Okay. First term 1 by f of theta, theta cube minus theta square plus 2 into e power z. So this is of 1 by f of theta into e power az form, right? Where f of theta is theta cube minus theta square plus 2, and compare e power z with e power az. Then for a equals to 1, we'll find f of a, which is equals to f of 1. Just replace theta by 1, we'll get 1 cube minus 1 square plus 2, which is equals to 1 minus 1 plus 2. Plus 1 minus 1 gets cancelled and you'll get 2, which is non-zero. Since the denominator is non-zero, by replacing theta by 1, or since f of 1 is non-zero, so we'll replace theta by 1 in the denominator. We'll get 1 cube 1 minus 1 plus 2 into e power z, which is equals to 1 by 2 into e power z. Okay, if we get denominator 0 by replacing theta by 1, we'll just something like this. We'll get something like 1 by 0 into e power z. Since 1 by 0 is undefined, so total term becomes undefined. So always remember that the denominator must be non-zero, right? Now, we are having 1 in terms of z, but we need to have in terms of x. So what we'll do is, we'll just replace e power z by x. Then we'll get 1 by 2 into, just replace e power z by x, we'll get 1 by 2 into x, which is equals to x by 2. So the result obtained from the first term is x by 2. Okay. Now, let's find the second term. E power minus z. This is also of 1 by f of theta into e power az, right? Where f of theta is theta cube minus theta square plus 2. Now compare e power minus z with e power az. Then for a equals to minus 1, we'll find f of a, which is equals to f of minus 1. Just replace theta by minus 1. We'll get minus 1 whole cube minus of minus 1 whole square plus 2. This is equals to minus 1 whole cube is minus 1, minus of minus 1 whole square is 1 plus 2. This is equals to minus 1 is minus 2 plus 2, which is equals to 0. So by replacing theta by minus 1 in the denominator, we'll get 1 by 0 into e power minus z. Since 1 by 0 is undefined, so total term becomes undefined. So we'll not go for theta equals to minus 1 now. Okay, since f of minus 1 is 0. So what we'll do now, we'll just write one independent variable z into 1 by, find the derivative of f of theta. We are having f of theta is equals to theta cube minus theta square plus 2, right? Let's find f dash of theta. This is equals to 3 theta square minus 2 theta, and derivative of a constant with respect to z is 0, right? Okay, with respect to z, yeah, is 0. Now, let's find f dash of minus 1. We'll get see here we are having theta cube theta square plus 2, right? We are having function of theta. So derivative of theta cube with respect to theta will be 3 theta square, and derivative of theta square with respect to theta will be 2 theta, and derivative of a constant is 0, right? Now find f dash of minus 1. We'll get 3 into minus 1 whole square minus 2 into minus 1, which is equals to 3 into minus 1 whole square is 1 minus into minus plus 2, which is equals to 3 plus 2, 5, non-zero, right? So we'll get non-zero. Fine. Now just write the derivative of f of theta, that is f dash of theta. Will get 3 theta square minus 2 theta into e power minus z. Since f dash of minus 1 is non-zero, so we can replace theta by minus 1 here. This becomes z into 1 by 3 into minus 1 whole square minus 2 into minus 1 into e power minus z. This is equals to z into 1 by 3 into minus 1 whole square is 1 minus into minus plus 2 into e power minus z. This equals to z into 1 by 3 into 1, 3 plus 2 is 5 into e power minus z, which is equals to z e power minus z by 5. Now we are having second one in terms of z, but we need to write in terms of x. So we'll replace e power z by x and z by log x. Okay, we'll replace e power z by x and z by log x. So in order to replace e power z by x here, we need to write e power minus z as e power z whole inverse. We'll just write e power minus z as e power z power minus 1 by this 5. Now just replace z by log x and e power z by x. We'll get log x into x inverse by 5. Okay. We know that x power minus n equals to 1 by x power n. Then we can write x inverse as 1 by x. Then we'll get, or we can just write it as log x by 5 into x inverse. Okay, for our convenience. This equals to log x by 5 into, write x inverse as 1 by x. Okay, we'll get into 1 by x, which is equals to log x into 1 is log x by x. 5 into x is 5x. So the result obtained from the second one is log x by 5x. Now coming to yp. Yp becomes, result obtained from the first term is x by 2 plus result obtained from the second term is log x by 5x, right? We can write it as 10 into x by 2 plus 10 into log x by 5x. 2 ones are 2 5s are, 5 ones are 5 2s are. Then yp becomes 5x plus 2 log x by x, or 5x plus 2 by x into log x. So we got yp and yc. Let's write the general solution now. The general solution is given by y equal to yc plus yp. Then y equal to yc we have, firstly I am going to write for the first yc, c1x inverse plus x times c2 cos of log x plus c3 sin of log x plus yp, 5x plus 2 by x log x, or we can go for the second yc, c1 by x plus x times c2 cos of log x plus c3 sin of log x plus yp. Okay, you can get any of these two answers. So this completes the problem. So we have seen a problem from higher order linear differential equations with variable questions in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.